Alright, Algebra 1B, welcome back. We made it to the second unit. Oh my god, that's so exciting. So our second unit is going to be all about exponents and the ways that we can work with exponents. We're also going to talk a little bit about radicals, right? So we're not quite there yet, but we'll get there. So the first thing we're going to do is we're going to talk about products and powers of powers. So the first one of these is going to be pretty easy because we kind of used it last unit when we were talking about polynomials. So what we're going to do is we're going to take a look at some of these. We're going to try and figure out, what the general rule is for them. Right? You might already be thinking like, oh, I know what to do with this. Right? X to the 7th means that I have 7 x's all multiplying each other. Right? So 3, 4, 5, 6, 7. Right? That's all what x to the 7th means. Right? When we've got x to the 4th, we got 1, 2, 3, 4 of those all together right over there. Right? And we're multiplying these together. So all together, right, if I'm trying to figure out a more compact way to write this than x times x times x all the way down, right, I'm just counting up how many of them I have. Right? So I had 7 in the first group, I had 4 in the second group, so all together there's 11 x's. Again, we took a look at this a little bit last week or the week before. That means that we have 11 x's all together, so I can write it as x to the 11th. Right? Instead of going over to b, let's just do c real quick, right? I've got 3 different things, right? I could write this all out as t times t times t times the other 4 t's in the middle times the other 6 t's at the end. 4, 5, 6, right? And when I have all those t's in order, not only does it make me want to go ta 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 ta, right? It also tells me how many I have, right? All together, that's 13 t's, so we'd say it is t to the 13th. Right? So if you're catching on to the little drift here, right, all we're really doing is we're adding those exponents together. Right? If I had 6 y's and then I'm multiplying by 8 more, I now have 14 of them. For the z's, this one's a little bit tricky. It's got a z to the 0, which is something we'll talk about at some point. I had 0 times another 5, which puts me up at 5, and then 6, 7, 8, 9. Right? So literally all I'm doing is I'm just adding all those exponents together. That's z to the 9th. And so this brings us to our first property of this unit, the product of powers property. So what this is telling me is that if I have something like, let's say, a to the m power, and I multiply it by a to the n power, what I get out is I get a to the m plus n power. Right? There's a couple little things that we got to be careful with here. Right? So you might notice that in all of these examples we've been doing so far, like these both have a. Those things match. Right? So when we're talking about things with exponents, this a is what we would call the base. Right? So in order to use most of these properties at least, you're going to need to have the same base on the things that you're trying to use it for. Right? Like if this was a to the m times b to the n, I couldn't use this property, right? Because they're different. So if I have the same base, I'm able to do this, right? These little things on their shoulders, those are the exponents, right? Or the powers, right? So the powers don't necessarily need to match, right? We're going to kind of get into how to handle the exponents themselves, but the important part is that the bases match. All right? So whenever I do 2 things with the same base, we don't change what that base is, right? Like we're going to take a look at that example 1 right below here. It's got some 3's. We're not necessarily going to turn it into 9 to the 8th, right? It keeps the same base the whole way through when we're just working with the exponents. Okay. So like I just said, right? This one down here, we've got the same base, right? They both have 3's, so that's good. We can use that property. So if I had 2 3's multiplying each other, and then I had 6 more 3's all multiplying each other, then altogether I have 8 3's all multiplying each other, right? 2 plus 6 gave me that 8. Oops. If it helps you visualize it, 2 and the 6, 2 plus 6 is what got me to there. And so literally all we're doing is we're just adding together the exponents. Right. Ooh, this one looks tough. Eugh. But really, it's really not so bad, right? The base is -6. Just happens to be in parentheses, but that's okay, right? It's -6 on both of them. We have the same base. We can use that same property. So what I'm going to do is I'm going to put down that same exact base, -6 in the parentheses and all, and then I'm going to put that power on there, right? So I had 5, I multiplied by another 5, so all together, how many -6's did I have multiplying each other? There were 10 of them total. Right? Don't fall into the trap where it's like, oh, I'm multiplying. Let's do 5 times 5. It gives me 25, right? Because we're multiplying the bases, we're only incrementing the exponent by however many more we were multiplying by. All right, so it turns into addition there. All right, for number 3, kind of the same deal. Right? Oh dear, I'm noticing a couple different bases, right? I have some R's, those match. I have some S's that match. Right? So whenever we've got different things, right, we're only matching them up with the ones that have the same base. All right, so when I'm doing my answer out over here, I know I'm going to have some R's, because I had a couple of those underlined in red. What I'm going to need to do is I'm going to need to take this 9, and then I'm multiplying by 7 more, which is going to give me 16 of those. All right. After that, then I'm taking a look at the S's. And all we're going to do is we're just going to put them right next to each other. So for the S's, let's choose a different color here. I had 5 that I was multiplying, and then I am now multiplying by 2 more S's. So altogether, I have 7 S's. Hopefully it doesn't seem so bad, right? It's just matching up the ones and smushing them together when they match. Same kind of deal for number 4 here, right? I'm going to take all of these W's, those will go together. All of these K's will also go together. And so when I'm looking at how many W's I have overall, right, I had 4 in the front, and then I multiplied by another 2 W's, so altogether that's 6 W's. For the K's, right, way up at the front I had 9, then I multiplied by 3 more, so I'm up to 12, and then I'm adding on another 4, which brings me all the way up to 16. Right? So again, we're just adding them together. You don't need to put the little brackets under them or anything like I'm doing, right? Let's try number 5 without doing those. Right? What you can do when you're writing out your answer is just take care of one variable at a time. So what I'm going to do is I'm just going to focus on the x's for this one. I had 5, and then I multiplied by a -2. So when I'm kind of smushing those together, right, it's like 5 minus 2. 5 minus 2 tells me that I have 3 x's left, all multiplying. As for the y's, kind of the same idea. Right? I had 3, and then I multiplied by another 9 y's, so altogether I have 12 of those. Hopefully it doesn't seem so bad, right? If you're thinking to yourself like, wow, this seems easy, what's the catch? Honestly, there's no catch, right? It's kind of nice. And so laws of exponents, when you're just working on one at a time, there's really nothing too scary about them. Right? Let's take a look at another property. So we're going to try and again kind of figure out what the rule is for when you've got a situation that looks like this, right? So what I've got is I've got 5 squared in parentheses, and I'm raising it to the 4th power. And so the first thing I'm going to do is I'm going to say, oh yeah, 5 squared to the 4th. So because it's to the 4th, that means that I have 5 squared times itself 4 times. Right? So what I'm going to do is I can write it out sort of like this. Right? I have 5 squared multiplied by itself 4 times. I have 5 squared to the 4th. Oh boy. So this doesn't look that great, we'll admit. You're kind of thinking like, ew, yuck. Right? But now it looks like one of the problems we were just taking a look at on the last page. Right? All of these bases match. Right? They all have a base of 5, and we're multiplying them. So all I need to do is just add the exponents together. Right? I have 2, 4, 6, 8 of them. So this is 5 to the 8th. Right? So take a second, think about what we might be able to do with 2 and 4, right? What we can do with these exponents that can kind of shortcut us to getting 8. Right. Let's try another one out and let's see if it kind of becomes a little clearer. So now I've got 3 to the 8th in parentheses, all to the 3rd. All right, so just like the last one, being to the 3rd power means that it's like I've got 3 to the 8th times itself 3 times. 3 to the 8th times 3 to the 8th times 3 to the 8th. Right? If you really, really, really wanted to, you could write out, like, oh, this is 3 times 3 times 3, 8 times. This one's 3. Don't bother with that, right? Hopefully we don't have to do that. That's why we have all these nice properties to help us out. So again, this turns into a problem like we were talking about right at the start. These all have a base of 3. We're multiplying these things that have the same base, so I just add their exponents together. All right, so 8 plus 8 is 16, and then 16 plus that last 8 is going to give me 24. This is actually 3 to the 24th. All right, so, we went 5 squared to the 4th, and we ended up with an 8. We went 3 to the 8th to the 3rd, and we ended up with 24. So our little shortcut way of handling these types of problems is to multiply the exponents. So if I've got something that looks sort of like this, right? Say I had a to the m in parentheses, and I put the n power on the outside, right? We're taking a power of a power, right? So what I do is I then do a to the m times n. Right? I multiply the powers together when we've got a situation like this. Right? And that's really a shortcut way. Right? So if I had x squared to the 4th, all I know I need to do is just multiply the 2 and the 4. That's going to give us x to the 8th. Bingo, bango, bongo, we're done. That's it. Taking a look at number 7, same kind of deal. I have x to the 6th in parentheses, all to the 5th power. This is going to give me x to the 6 times 5, which is 30. Cool. Oh no, oh dear, what have we done? Oh gee. So sometimes, we're going to run into problems where we've got a couple different things going on, right? And, there are sometimes a couple different ways to approach the problem, right? So one of the ways that we're going to talk through these is, we're going to take care of parentheses first. Right? If you think back to when you learned about order of operations way back in the day, right, we want to take care of parentheses first and get that all done. So if I'm just focused on the stuff with the parentheses, I've got m to the 4th to the 2nd. Right, so we're going to use the property that we were just learning about. So what this will turn into, we'll keep that 3m in the front, and then m to the 4th to the 2nd, we multiply the 4 and the 2 to give us 8. So then the question comes, like, what am I doing, like, what's going on in between these? Like, that's awfully weird. So whenever you've got stuff that's, like, outside parentheses, and then you've got some parentheses with stuff inside, what's really going on there is that those things are multiplying. Alright, so this is actually 3m times m to the 8th. Alright, so then it does turn into one of those problems we did at the start. Right, we have an m over here, multiplying by another thing that has an m. Right, but the question is, what are we doing? We were talking about adding exponents. So there's nothing in this little space up above that m. Well, something we talked about when we were doing polynomials is that if it doesn't have an exponent that's already listed there, right, think about how many are there. If I have m, I have one m. It's just one of them, so m to the 1st. Okay. The other little tricky piece about this is that we also have this 3, and this 3 didn't really have anything to multiply with, but we still want to bring it along with us. So what I do is I have 3, right, just bring it along, and then we can squish the m's together. Right, so if I add one m, and then I multiplied by another 8 m's, altogether that means that I have 9 of them, right? It's kind of easy to make a mistake and just say, oh, yep, I got 8 of them total, right? Because you forget to put that little 1 up top. All right, so put that little 1 up top. Give yourself that reminder, because now we have 9 m's all multiplying each other. Okay. Let's try 9 out, right? Same kind of idea. I'm going to start with just the stuff, including the parentheses. All right. So that 2g is just going to come along for the ride. All right. When we have g to the 3rd, in the parentheses to the 9th power, we multiply 3 times 9. That gives us 27. Alright, so very similar to the last one, we're multiplying these things. These both have g. That first piece with 2g, it's 2g to the 1st, right? There is a g there. Right? So I'm going to bring along the 2, and then altogether for the g's, I have 28 of them. Right? Looks kind of gross, right? Like, oh, 2g to the 28th just like makes your skin crawl a little bit. But the nice part is that with these problems, we're not going any further than that right now. Right? We're just kind of getting to there, and that's it. We've simplified it. Like, take that problem, we're done. Right? Some other things that we may run into are problems that look like these. Right? And again, we're just going to take it one piece at a time. They look pretty awful, like 4x to the 5th times 6 in parentheses, x to the 3rd to the 4th. Blah, blah. Makes you just want to, like, curl up in a ball and cry a little bit. Right? But it's going to be alright. Right? We'll start with a parenthesis, just like we did before. Right? So I'm going to bring along everything else, right? 4x to the 5th, haven't touched it yet. Going to bring it along. Got that multiplying, we've got that 6. And then the stuff that I highlighted over there, x to the 3rd to the 4th, it's going to give us x to the 12th. Okay? So now, this problem looks a little bit closer to something we were doing in the last unit with polynomials, right? If I gave you a problem that looked like this, right, that's something that we started off doing when we were talking about the multiplying of polynomials. So it's going to be kind of the same deal as what we did back then. Right? It just looks a little bit different because it's got that actual multiplying sign done out for us. What I'm going to do is I'm going to multiply the pieces that go together. So 4 and 6 would multiply each other. These x's would also multiply. Right? So 4 times 6 is 24. If I add x to the 5th, and then I'm multiplying by x to the 12th altogether, I'm going to get x to the 17th. Right? So just take it one piece at a time. There's no need to go like straight from way over here and jump straight to your answer. Right? We can take that step in the middle. Right? It's alright. Oh boy, one last one. So same kind of idea, right? I'm going to leave that last one up as an example to kind of follow along with. So we've got this stuff in the parentheses here. I'm just going to start with that. Alright, so again, I'm bringing everything else along. We had negative 3, x to the negative 7. We've got that times, and we've got the 9. Alright, so haven't done much of anything other than just copying. The stuff in the highlighted part, x to the 4th to the 3rd, 4 times 3 gives us 12. So that's going to be x to the 12th. Same thing as the last one. Right? I have negative 3 times 9. Those can multiply together. We got x to the negative 7th and x to the positive 12th. Those can multiply together. Right? So negative 3 times 9 is going to give us negative 27. When we take care of those x's, right, x to the negative 7th times x to the positive 12th, I'm adding those exponents together. Right? So negative 7 plus 12 is going to spit us out at positive 5. Okay. Well, wow, I think that's it. Sure is. We're already done. Not too bad. And so as always, be sure to check on Google Classroom for any additional resources and or assignments, and reach out to your teacher if you have questions. I'm out of here.